for having me. This has been an interesting topic. How many of you have tested your backups? Just a few hands. How many of you actually do that for a reason that's not compliance? Right? So my presentation's on something very interesting. We all anticipate that backups are what we expect them to be. And we started this project in an interesting way where we had a customer, and I can't name the vendor and I can't name this customer, but this customer engaged us to unpack this proprietary backup, which is used by several of the top vendors, some of which are here at this conference. But this ABC Inc., their objectives were to do several things. They're very reasonable, very pragmatic things. They wanted to look at vulnerabilities in offline images because they weren't allowed to install endpoints, which is common. We all have seen that situation. They wanted to get intelligence on the components, see if there's malware as part of the distribution process. They also wanted to have attestation between SAT and FAT and dealing with their golden rolling images. I mean, quite frankly, if there's a ransomware incident and you just installed a big machine cell or a big machine, and there's ransomware, who's the company going to point fingers at first? Probably you, the contractor who was doing the technological churn. So really what they wanted to do wasn't just for rear-end coverage. They also wanted to see what they were doing right, what they were doing wrong, what they could do better. They wanted to have culpability, or to avoid culpability with rising from cyber incidents or events. And they wanted to create SBOMs for compliance reasons. So from that point of view, have you all ever had a project turn out the way that you thought it was going to? How many? Hands up. Not many, right? How many projects really turn out well? Well, this one turned out a lot different. But we realized very early on, does anyone actually evaluate the backup formats and the quality of the backup solution providers themselves? So backups and recovery are really table stakes. There's almost everybody that's got a solution here. All the SMEs, they talk about it. I don't think there's a framework that doesn't. But did any of us ever ask, besides testing, and a cursory test at that, have we ever executed a tabletop exercise where we can't find the license keys for that solution? Have we ensured that the solution is good and of high quality? Well, we all remember how backups looked on Windows XP and Windows NT. They were good times. We remember how they started to change with Windows Vista. And there's those frameworks. And even 62443 discusses it to a fair degree. So why does this matter? And we thought about this. I've gone through the process of looking at some of these other solutions, some of the formats as part of our business. But that's not why I'm here. I'm here because of a human condition. Now, looking at these things, we started to think, Clonezilla, is it GPL, open source, many file systems? Some of us might remember the days of Norton Ghost. That was a lot of fun, seeing that blue screen with the gray 8-bit graphics. You had lots of NIX support with Clonezilla. And then along came Microsoft with their WIM format, which used to be only Windows only. But now it supports Linux. Great. There's different mechanisms, different compression, and I'm kind of leading you towards the fundamental building blocks that go into these products. Now again, like I said, I have anonymized it. You will probably can figure out who that backup vendor is. They offer flashy features. They have exportable functionality for VMs based off of real boxes. They have a centralized server model with tooling and even a cloud-based solution now. They sometimes have standalone tools. They're supposed to be free, but they're all pre-compiled. And their backups, quite frankly, are unsupported and unknown formats. So we went down this process. And OB File Kenobi here, he didn't find the file clones, or the disk clones that we were looking for. It just didn't happen that way. So we tried an ad hoc exploratory process to go through this. And this kind of walks you through how the team we reverse engineered this format. It turned into we just didn't reverse engineer the format. We also did a major NTFS volume work from scratch. There's not that much code out there. There's not that much documentation that does it well. So we built different data sets based on a scalable size because we anticipated to reduce the size of a backup, you will have differences that start to appear. And you might see it very easily and you think you can manage it on a small volume, but as that volume gets bigger, it doesn't work that way. So we started with snapshots, virtual drives, and started comparing them at the bit level. And we used test files that exceeded the file system's block size so we could see if it got moved around and cut into sections. We walked through the original drives. We looked through the backup images for completeness, for markers that we could use then to validate our hypothesis, and also the presence and the completeness of our test file. We assembled it. We contrasted it. We looked at the deltas, and we concluded these were not the files we were looking for. And that's where we started to go, oh wow, we're onto something. So what we discovered was they're the same, but different. And that starts to make us wonder about if we're going to recover, or can we trust a backup for legal reasons? Is it forensic? Is it not? Well, this vendor is not. So this is kind of a basic kind of premise. This is how we got started. You look for some basic structures. You start looking for things like, okay, do we have some magic, if you're lucky? This is very, very simplistic stuff. There's a footer in reverse, but then you got to rewind it to go find the metadata. And this is a split archive. So this is marking a 2 of 9 for this volume. However, the splitting has thresholds. It can be automatic. It can be preferred, let's say, for DVDs or Blu-rays. Unfortunately, there's bugs in the splitting. But that's not the main premise. That was just how we got started. Then we started looking at the metadata about the host and the backup. Because in some countries, you are mandated to put your backup into a government or a country-owned provider or data center. So if you're worried about some of your operational data leaking out, and some of these used to keep this separate, well, these newer versions are actually including it into the backups themselves. And then we started also looking at it and seeing what else was involved here. And we started seeing the Microsoft shadow service happening for the volumes too. So here, like I said, you're probably leaking data from your backups unless you're encrypting them before you send them out. Okay, compression, that's not a big problem, except until it is. So we noticed they had some naive compression. There's markers. There's all of the easy things that you can go find, except there was 2 types. And the more concerning one was the headerless streaming of zlib, because you needed to know exactly where it was and how it was being used to reassemble it. You didn't know how much of a space you were dealing with. Yeah, they had Z standard on the newer editions, but we didn't bother to deal with that because we had our hands full here. But you'll notice here that often the compressed data was in line with the backup. So unless you know the exact binary structures and how to stitch it together, the block sizes, all of those things, you won't be able to put it all back together unless you have the real drive in front of you, which in an emergency, you probably don't. So we started with the easy things. Okay, we dealt with the headers, the trailers, putting the archives together that were split, except the concatenation didn't work. We knew we had some work cut out for us here. We thought, okay, what else can we do? So we exported the VMDKs just to validate the solution from a different angle. And the file system, which was NTFS, was corrupt. Somehow Windows knows how to fix it. I personally don't quite know it enough. The gentleman that worked with me on this project, brilliant as he is, we still struggled. We found white space was trimmed from the MFTs and the clusters, which can be okay for the purposes of saving space and to make a very quick backup. However, this was even on the one designated with no compression. So we realized, okay, what else is going on? We looked at the MFTs, the files. We thought, okay, what's going on here? But the addressing didn't make sense. We noticed there was slack space now missing in some cases, and then there was other stuff that was added onto tails. But the raw backups also had other issues. It's not fixable with any tool, except theirs. So you're locked into that vendor. So for your most important capability of backup and recovery, this is probably not a strategy that's a winning one. We also realized that, especially on a contiguous volume that we created, they were reordering all of their blocks and their structures. Their pages were different offsets from the file systems. And we also noticed new entries in the file tables. Not something I was hoping to see that day. But it gets better. So what we were doing, we mapped it out. We walked through the entire file system, including the bootloaders. And we started to notice things. We noticed that they were reconstructing that NTFS volume with actually what they thought was a signed integer, but it was an unsigned integer, so we were winding up with wraparound cases and addressing that didn't line up, even if it was in the right location. Then we thought, okay, so how do we stitch all this back together? So we went through this extremely tedious exercise of building out a monstrous spreadsheet of every single page. Now, on a small file system of, let's say, 1 gigabyte, that's a reasonable activity. It's not a reasonable activity on a 1 terabyte drive. So some of you might be familiar with NTFS file holes. These are different kind of file holes. These are more like sparse blocks that are unallocated. So when you want to stitch all this back together, you need to know the offsets of your data to the trees, or you'll have to recreate the entire file system to scratch to find your files. The blocks of the archived data were actually partials of the actual blocks. And actually, if you look at those Fs on the bit masks, there actually wasn't enough Fs to fill in the spaces for the holes. We found, of course, there was some CRCs hiding in there. But interestingly enough, the volume itself was unaware of the changes. And if you don't have the original like a real bit-by-bit backup, and how would you map it to the original without knowing those things? So we walked through it. Okay, we found the CRC there. It's quite easy to anticipate the bit shifts. They're all base 2. They align to an arbitrary page size. Sometimes you could get coincidences, but it wasn't in hard-coded. It wasn't enough to calculate it from any of the values in the trailers or the headers. And also, the bit shifts and the bit maps actually started to do things. So you notice with those Fs and zeros, we thought at first we could anticipate and shift along and kind of fill in the blanks. That turned out not to be the case because there's data being stored somewhere else. So as we kind of walked through this, we tried with another small volume. But we've gradually increased the volume size and spending tedious hours again on those spreadsheets. But on larger volumes, the holes got bigger and more random, which means they are running some sort of custom compression format to deal with all of the things that are found, the subcomponents. All of that was starting to play here. Now again, we started this for the premise of trying to understand a backup format, not a file system. So we had to go the entire pathway from start to finish. So again, you can see here, there's another pattern of bit shifts, but the sizing just doesn't align with anything else that we knew previously, not even the page size. There was another strategy that they were employing to make sure that the data was, or it had integrity and it could be validated, which is a great function. We all should be doing this, especially on file systems and backups. But if you had one hash mismatch, your entire volume was invalidated. So your backup was not worth the paper that it was printed on. So good backup, it was just Boolean. So you can throw it right out. Now, to try and find where we thought that data was going to be, we looked near the tail of this file. So we rewound from that trailer. And we started to spot some things, some patterns that we could acknowledge, things that we knew or were trying to align to a human perception. Humans are really good at pattern matching. We're darn good at it. So we started looking, and we saw these tables, and they grew almost with that same size of the evolution of the volumes. We thought they were encoded. They were. We don't quite know what all the structures were. We suspect it's actually mapped to a custom form of bitmap compression, not often seen for those things, usually on embedded systems more so. Or it was something that was akin to virtual clusters and sectors, so they were faking a disk. At least that's what we thought. Another hypothesis we had, well, without a salt, we were hoping they weren't salting things, and maybe that's still true. But the hashes were consistent where the blocks were all zeros. So where we could find that, we found the same hashes every time, so, or whatever these values might have been. But the size of these values didn't align to any of the typical cryptographic hashing primitives. And when we couldn't find a collision, because we would try, we knew what all the zeros were, we knew what the data was, we still couldn't get a collision. So this seems to be there's an array or a table of ambiguous values, but then we started going online. And we started following this vendor, and we started looking at who created and filed patents. And we started to get hints to the logic of this backup. So looking again at these table values, we can see that there's a pattern emerging. Not always consistent. Maybe it kind of shifts as the algorithm works. But we notice this one little block here. Compile a list of data storage in blocks. That maps to a very verifiable hypothesis here, where this is the first step in that journey. And those repeating values were always consistent within the backup. So where we knew there were zeros even across different backups, they would map to a corresponding row in this table. Now we presumed, after reading some of the documentation from the vendor, looking at other patents, just applying some common sense, we thought this was to dedupe the blocks, to get rid of sparse holes. But they weren't predictable. And that started to make us really concerned. The pages were inconsistent. It didn't make sense to the size of the data we were trying to reconstruct. And the bitmaps, again, were linked to this table. Now, again, we looked again at the schematics. We can see here that they're incrementing roughly in tandem with their page size from start to finish, and that would grow also in tandem with the size of the volumes. So looking at documentation are all the zeros in the bitmap. So we're starting to build a very, very strong strategy here to look at this file format. Now, there's more, of course. Read sectors from local storage. This kind of makes more sense on a very populated and highly dense volume again. And as we kind of walk through this, we're like, okay, remember that Microsoft Shadow service? Now, I don't personally know much about it. I know it's often used in boxes running Exchange servers. It's done to actually back up the data that is currently in use without causing corruption or some sort of error on a read. And then there was other kinds of backups also from this vendor. They had forensic ones. They were dumping memory in there. Who knows what else would have been in there. They required you to boot a custom operating system to actually deploy this. They had some of their own encryption. They had some integrity checks that were kind of iffy. But this posed more questions to us. It's all about the quality of the backup format and the solution provider. Maybe it's very good, maybe it's not. But when we started reading the documentation from Microsoft about the shadow copy, it said software providers, and in this case there was a software provider that was part of the solution. They typically, they actually will inject themselves into the system calls, and they will start to subscribe the data from the volumes, from the operating system, from the kernel. They can issue read and write requests, which kind of works with what we understood from the backups. We knew that there was a file system involved, there's a volume manager, but the thing is that you don't have to use Microsoft's components to do this. You can write your own. And this vendor wrote their own. So again, diving into the operating system stuff, Microsoft kind of mentioned something here. Your backup solution can now become a kernel-level access backdoor. Right? I see it. Everyone's nodding their head. Well, you have one that's in user land in the operating system to kind of, I'm assuming, to transfer software interface with the backup solution. And there's one kernel mode device driver. Now, we all know kernel mode drivers are a bit of a scary thing. We know people like to steal keys so they can get automatic or certify them, get them automatically injected into the Windows kernel. And again, reading at that documentation, we were looking for the shadow services SKUID, and we couldn't find it. But that was the main point. That was the scary part for us. And also, tying this all in, looking at the big picture from Microsoft, there's a lot of extra pieces there that were not just this third-party vendor solution provider. But this was the part that made us wonder. Nobody likes blue screens. Nobody likes the possibility of an oops, especially if there's changes in the ABI for the file system, the kernel operating system. You can have some data being reinterpreted or being siphoned off, and it could also be abused for a backdoor. But this is the main piece here. ICS is not meant to be a creative art form. We are not supposed to take liberties on designing this type of work. Lights are supposed to be on, water flowing. So these are two concepts, but this is the wrong industry for art. So this backup solution, it works. But what about it? It's bundled by several of your top tier vendors globally. It's highly proprietary. It's incompatible with open source. Now, I personally don't have a problem with either or. There's pros and cons to each, but there's no alternatives existing for unpacking these backups. So when you're looking to do so in an emergency, I'm really wanting something that has the highest chance of me recovering fast, because downtime is not the best thing ever. We want to be able to do it headless. We want to be able to script it, make it a repeatable, continuous process. Unfortunately, when you use this software, it's supposed to be free, you have to use their UI. So you have to click through it and add extra steps to something that should be automated and completely almost reactive if you have an incident. Now, there's nothing wrong with a partial backup. You know, your grandmother's photos, you don't really mind if, you know, a bit gets flipped here and there or it misses the local, you know, the thumbnail archive. But when I'm dealing with a primary, secondary controller or a Windows HMI, I really want my backup to look like what I had before or my last known good validated image. In this case, we know the volume was tampered. So in a time of panic, this is not the best time to be playing these games. So there's kind of 3 questions here that I'd ask, that not just about this backup. Is the solution or the copy or all those things, are you ready to recover? Now, I've known many PLC PLC owners, asset owners, who don't even have access to their engineering software keys on site. Often some third party has them that does the deployment. Well, this is kind of probably going to be true for your backup. You have to go call corporate IT to go get your keys. That should be fun, especially if it's going through some sort of automated ticket system. Do you have enough bandwidth to even recover at scale? I've been to a lot of facilities that only have 1.5, 10 megabit downloads. Their uploads are slow too. That's not what you want either to recover. But looking at this, starting to kind of solidify and focus on things like NIST2, NERCSIP 010, 013, do you know where that came from? What was the process along those lines? And then this got us to the next point. Is your backup vendor subject to or could be affected by a sanction? How many of you were around when Kaspersky was banned from North America? Was it a good time? No, it wasn't. I was with you on that one. Now, I'm not naming this vendor for a reason, because there's all sorts of business reasons and there's geopolitical problems right now, challenges. But the optics can actually inform our lawmakers to make something that's going to make our bad day much worse. It could give them a strategic advantage should they wish to. Now, I spoke with the digital officer from, or one of the main top digital officers for Red Cross. Sanctions are one of the worst things when you're responding to an incident. I suspect they had a certain cellular modem company that they had all these, crash carts of gear to go out to all of these different incidents in society. And they said that was not a good time. There's an emergency. You don't want to deal with the risk exception or getting a fast path for a temporary allowance. So the optics of this vendor, its partners, can really represent a significant cause for concern. So starting here, we looked at some open source data about this product, this vendor, and you guys can figure all this out. But they were saying, we're not Russian. We are not built in Russia, headquartered in this country. They're over there. Okay, and now we found stuff. Okay, let's look at their compression algorithms. Let's look at those documents that we found, the patents. Well, they were from a country that some of us are not very comfortable with at the moment. But again, you notice in that bottom one there, under generation archive format, and it's talking about adaptive compression. Again, that's tying back to my bitmaps. Well, it turns out that this company has all sorts of footprints that are misinformation for all of us. The JSC was involved as a premium partner for this vendor. This backup vendor also has several other names in different countries, but it is all the same thing. The engineers that worked for them after that announcement on the left-hand side about we're not Russian, they would go to Serbia, but they're still working for them. And my favorite part down below there is I can see he's working on reverse engineering the Windows drivers. So this individual is clearly still working for them. Now, that may or may not be a risk that some of us are willing to tolerate, but better yet, I'm not quite sure how ABB thinks that this is made in Germany or United States. Maybe that's where they burn the DVD or pack up the software, but that's certainly not where those components come from. So to my friend that works at Red Cross, this is not going to be a good day. But again, that depends on our risk appetite and how we want to make our decisions. So to Dale's point also, I like to think about strong constructive things. This is designed to make you think. I certainly thought about this. We look back a little bit at history. We all remember how wonderful Windows NT backups were. Not a good time. And these vendors came out as a solution to a very severe and significant pain problem. Vista came out, or previously also known as Longhorn. They came out with this new format called WIM. VMware released their converters for tombstoning. I hope it comes back, except they got rid of that. Then you got sanctions. Then you ended up having ransomware come out in mass. And now we're here. We've got our most important capability without a way to openly back it up. I don't care if it's a proprietary solution, personally. I do care about the backup format being repeatable and open and basically verifiable. So we need open standards. That's something I want to leave here for believing for the future. We need a new standard to do this. Whether it's WIM, I don't care. We need to do it in an open way. We need to validate the tools. We should have certain ones that are indeed validated from all sectors. And as a community, we need to verify this from start to finish. That's why we're here. We care about people. So my key takeaways here, before we wrap up for a couple questions, is backups are not always replicas. You really need to verify this. There can be tampering, missing bytes. There can be bit flips, or you could wind up with bit rot with your backups. Some things are just not meant to be backup ready. BTRFS is one of those things. Open backup standards are required. The formats can be open, but the solution, well, that's one other thing altogether. Knowing who develops your backup solution is a necessity. It's not optional. It often gets bundled with Seagate hard drives, for example. Should it? Not sure. But knowing the subcomponents are crucial factors in minimizing sanction and regulatory impacts, especially the overhead with 013 and other things like NIST 2. But in critical infrastructure, backups and recovery, it is your business. It is literally your business. It is your BCP. It is your DRP. It is your business as usual. They're an ICS, OT, enterprise, doesn't matter. It's not just a compliance tick box. It's your contingency during an event, whether it's malicious, unintended, or otherwise. So these are my takeaways. I hope you enjoyed that, and we can all go home and think about this really dark, scary thought.
Thank you so much. Yeah, well,
thank you.
Yeah, good.